In this lecture, we are going to discuss some section of Chapter 8 and some section of Chapter 9. We will study some aspects of the periodic table and the valence electrons and ions. In the periodic table, we can identify groups and periods. The groups correspond to the column in the periodic table. There are two different kinds of group A and group B. In this course, we will focus on studying the groups A. When we study the electronic configuration, we conclude the elements in the first column they had one electron in the outermost shell. And the same happened with the second column, with 2A. They had 2 electrons in the outermost shell. And same happened with the other groups A. For example, the 7A, all the elements in this group, they had 7 electrons in the outermost shell. So we can conclude the Roman number along with the letter A correspond to the number of electrons in the outermost shell for each of the elements in the respective column. Also, we said the periods indicate the principal quantum number n, and these periods correspond to the principal quantum number, which is associated to the energy level. This is why the period 1 corresponds to the energy level n equal 1. The period 2 corresponds to the energy level n equal 2. And also the period 7 corresponds to the level energy n equal 7. The periodic table is divided into groups of elements that have similar characteristics. For example, the blue group corresponds to the metals. The orange group corresponds to the semiconductors. The blue group corresponds to the nonmetals, and the white group corresponds to the noble gases. Also, in the metal group, we have another subgroup that is called the transition metals. The noble gases group is a special group because they had 8 electrons in the outermost shell, except for helium that has 2 electrons. What happened is the elements, in order to be stable, they need 8 electrons in the outermost shell. This is called the octet rule. Because most of the noble gases, they had 8 electrons in the outermost shell, they are stable. And this is why they don't react with other elements. And helium, which is special noble gas, he is stable with 2 electrons in the outermost shell. The elements in the other groups will be stable if they had similar configuration to the close one gas noble. For example, lithium will be stable if it had the configuration of helium. And chlorine, for example, will be stable if it have the configuration of argon. It is why for the elements in the groups 1, 2, and 3, it is easier to lose electrons to be stable than gain electrons. So the metals really lose electrons in chemical reactions. On the other hand, nonmetals, mainly the groups 5, 6, and 7, tend to gain electrons in chemical reaction in order to be stable. In the case of the semiconductors, groups 3 and 4 may gain or lose electrons in chemical reactions. Let's talk a little more in detail about some of the groups A. For example, the group 1A is called the alkali because they react with water to form alkaline solutions. The elements in this group, in order to be stable, it means in order to have the electronic configuration similar to the noble gases, they react with the group 7, the halogens. Usually, the group 1A react with the group 7A. The group 2A is called the alkaline earth metals because they are reactive, but not as reactive as the group 1A. Also, they react with the halogens to be stable. The groups 7, 8 correspond to the halogens, and they are non-metals. They need just one electron to be stable, so usually they react with the alkaline or the alkaline elements. The group 8A correspond to the noble gases, and they don't react with other elements because they had filled the outermost shell. In the periodic table, you will also find additional information for each element. For example, in this case, we had carbon, and you will find the element name, the atomic number, which corresponds to the number of protons, and also, in case of the neutral atoms, the number of protons equals to the number of electrons. Also, you will find the symbol of the element and also the atomic mass. One more thing, I want you to remember that the mass number equals to the number of protons plus the number of neutrons. We know the number identifying each of the A groups corresponds to the number of electrons in the outermost shell, except for helium that is in the group 8, but helium has 2 electrons in the outermost shell. This information is important because the electrons in the outermost shell are responsible for the chemical reactions. We can represent these electrons using the electron dot notation. We can see the group 1A, all the elements in the groups 1A has 1 electron in the outermost shell. In the second group, or 2A, has 2 electrons in the outermost shell. And we can see that happen with the other groups. And also in case of the group 8A has 8 electrons in the outermost shell except for helium. To review, now we know the noble gases, they don't react with any other element because they had the outermost shell filled. Also, we can say they are inert. The groups with 1, 2, and 3 outer electrons, usually they will lose electrons to become positive ions, and the group 1, 2, 3. And this happens in the case of the metals, as 1, 2, and 3. The group 5 and 7, they tend to gain electrons to form negative ions, and this corresponds to the nonmetals. And semiconductors are intermediate between metals and non-metals. Let's summarize what we know up to now. First, the chemical behavior is determined by the outer electrons. The outer electrons are called the valence electrons. These outer shell electrons are represented using the electron dot notation, also is called the electron dot diagrams or Lewis structure. Also, we know the noble gases had complete filled the outer shells, and therefore they are stable and they don't react with any other element. All the other elements, all these elements, they react so as they fill their outer shell and become more stable. It means they become more like nearest noble gas. We know that neutral atoms, they had the same number of protons and the same number of electrons. Also, we had 2 types of ions. We had positive ions and negative ions. Let's explain what is a positive ion. In case of the lithium, in order to be stable, lithium needs to lose 1 electron. And we know the reason is if lithium is in the first group, lithium has 1 electron in the outermost shell. In order to be like helium, means to be stable, need to lose this electron. If lithium loses this electron, then the new electronic configuration will be like this one. and lithium will have 3 protons and 2 electrons. Then the net charge will be positive 1. This is why lithium is positive ion. So positive ions have more protons than electrons. And this is why the metals usually lose their outer electrons to acquired a noble gas structure and become positive ions or cations. For example, sodium needs to lose 1 electron to be similar to neon or acquired the electron configuration of neon, which is more stable. Or calcium needs to lose 2 electrons to become as argon, means to have the electron configuration of argon and be more stable. One example of the negative ion is fluorine. Fluorine needs to gain 1 electron in order to be more stable. Fluorine has 7 electrons in the outermost shell. To be stable, then need to gain 1 electron to be like neon, to have like neon structure. And this is why if fluorine gain 1 electron, then the new electronic configuration will be like that. In this case, fluorine has 9 protons and 10 electrons. Then the net charge will be negative 1. And this is why fluorine is minus, or you can write minus 1. So negative ions have more electrons than protons. And usually nonmetals gain electrons to acquire an outer noble gas structure and become negative ions or anion. For example, chlorine needs to gain 1 electron to be as argon, or bromine needs to gain 1 electron to be like krypton, or for example, oxygen needs to gain 2 electrons to be like neon. Then when these elements they gain 1 electron or 2 electrons, then become more stable because they had similar structure as the noble gases. One more example is sodium, which is a metal. And if it's a metal, must be a positive ion. Let's see. In the first picture here we had the electronic configuration for sodium. We had 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 electron in the third energy level. We can see the same if we write the electronic configuration. We had 1 electron in the first energy level. In the second energy level, we had 2 plus 6, 8 electrons, and we had 1 electron in the third energy level. To be stable, sodium needs to acquire the neon structure. So sodium needs to lose 1 electron, as we can see here in the abbreviated electron configuration. If sodium loses 1 electron, become positive ion. We can see sodium has 11 protons, and if it loses 1 electron, then the net charge will be positive 1. And this is why sodium is a positive ion, as we expected, because sodium is a metal material. We can see in this diagram, if sodium loses 1 electron, then the electronic configuration of the ion of sodium will be the same configuration of the neon. Another term that I would like to define is isotopes. We know the atoms of an element must have the same number of protons, because the number of protons identify the element. If the number of protons change, then you will have a different element. However, the number of neutrons may vary. Atoms of an element that have different number of neutrons are called isotopes. In this example, we had 3 different isotopes for hydrogen. We can see in all the cases we had the same number of protons, which correspond for the number of protons for hydrogen, but the number of neutrons is different. In the first isotope we had 0 neutrons. In the second isotope we had one neutron, and in the third isotope we had 2 neutrons. Also, we can represent the isotopes using the nuclear symbol. For the nuclear symbol, we will use the symbol of the chemical. The upper number corresponds to the mass number. The mass number is the number of protons plus the number of neutrons, and the lower number corresponds to the atomic number. Then we can see here, this is hydrogen, this is why we had here H. The mass number, we need to add the number of protons plus the number of neutrons will be 1, and the atomic number is 1, which corresponds to the number of protons. In the second case, the mass number is 2, because if we add these two numbers together, we will get 2, and the number of protons is 1. In the third case, if we add number of protons plus number of neutrons, we will have 3 on top, and on bottom we will have just 1, which corresponds to the number of protons. Let's summarize what we learned today. First, an element is composed of atoms that have the same atomic number, means they have the same number of protons. For example, hydrogen always will have 1 proton, copper will have 29 protons, and aluminum will have 13 protons. If the number of protons change, then we will have a different element. Second, a molecule is a particle that is composed of 2 or more atoms that held together by a chemical bond. For example, we have the water, or we have the carbon dioxide. The third term we learned today is the isotopes. Isotopes, we know, are atoms of an element with identical chemical properties, but they have different masses because they have different number of neutrons. Also, we say when an atom or molecule gains or loses 1 or more electrons, it becomes an ion. And we say there are 2 different types of ions. One is the cation, the other one is the anion. Cation occur when the element or molecule loses 1 or more electrons and therefore has a positive charge. In case of the anion, occur when the element or molecule gains 1 or more electron and therefore has a negative charge. And this is all I had to discuss for today.